welcome back. Today we're going to talk about factors and the beginnings of fractions. Factors are numbers that multiply together to get a certain number. So factors are numbers that multiply to get a certain number. And so if I say what are the factors of 6, they'd be 1 and 6, 2 and 3. And so what I'm going to show you is an easy way to find the factors of a number. 36. Let's find the factors of this number. Well, I'm going to go in pairs and you're going to see how this works. The factors of 36, let's start with 1. 1 times 36 is going to give me 36. Well, I also know that because it's even, 2 goes in. And I know that 2 times 18 is 36. I'm just going to kind of work my way up the line. And so I know that 3 times 12 is also 36. And 4 times 9 is also 36. And then I go to 5 doesn't go into 36. Does 6 go into 36? Yes, and 6 times 6 would be 36. So you see, you start from both ends, and when you meet in the middle, you run out of factors, okay? Let's look at 17. 17, I know that 1 and 17 go in. I know that 2 doesn't go in. I know that 3 doesn't go in. 4? No, 4 goes into 16. What about 5? No, 6, 7, 8, 9. And see, when you get over that halfway point, you know that if 8 times 2 was not 17, then you know that 9 can't be, because 9 would have had to have been 2. And then so 10, you know that's already bigger. So 1 and 17 are the only ones. That brings me into a discussion of prime and composite. So 17 is kind of special. It only has 2 factors, 1 and itself. That makes it a prime number. So if I skip down here, a prime number is a number with factors only 1 and itself. Okay, so the number 17, the number 13, the number 11, how about 5, how about 7? Those numbers only have 1 in themselves as factors. Okay, I'd like for you to try these two on your own. 45 and 19. Try to find the factors of those on your own. We talked about prime. Let's talk about composite. A number with factors other than 1 and itself. A good guideline would be like, if it's even, then it must be a composite number because it would have 1 and itself and also 2. That's a general guideline. How do we get down to what the factors of a number are? Well, we could list them out, or we could start to do factor trees. And when we use factor trees, which I'm sure you've seen before, we start to get down to something called prime factorization. Let's start with 49. If I start with 49, I'm going to pick 2 things that multiply together to get 49. And so I'll pick 7 times 7. Well, the key to a factor tree is when I get to a prime number, a number with only factors of 1 in itself, I stop. And so I know that the only things that multiply together to get 7 would be 1 and 7. And so I'm going to circle these prime numbers. And when I write the prime factorization down here, I'm just going to write 7 times 7, and that's 7 squared. This is the prime factorization of 49. Let's look at another one, 24. The question is, does it matter which way you start? Well, not really. So I'm going to start with 2 times 12 because I know that 2 goes in. Well, I immediately notice 2 is a prime number because it only has factors of 1 in itself. Then I keep going. 12 can then break into 2 times 6, right? Once again, 2 is one of those prime numbers. And 6 will break into 2 and 3. And I know that both 2 and 3 are prime numbers because they only have factors of 1 in themselves. So the prime factorization is going to be 2 times 2 times 2 times 3, which is 2 to the third times 3. That's the prime factorization of 24. So if you want to, you can write 24 equals. Okay? I'd like for you to try 52 on your own. If you don't know what goes into a number, pick 2, because if 2 works, you can just keep splitting that number in half. Let's talk about factoring monomials as the last piece here. Factoring the monomials is just putting together what we know about prime factorization and factor trees. Well, 12. If I factor 12, I get 2 times 6, and then 2 times 3. And so the prime factorization of 12 is 2 times 2 times 3. So here's how I factor this monomial. 2 times 2 times 3 times, and I have x times x times x, because that's x to the third, times y, because that would be 12x squared, x to the third, y squared. That's all you do. You just expand it out. In B, well, 3 is already prime, so 3 times m times n. That's the prime factorization. You see how that works. Factors. Breaking it down into prime pieces. That's all there is to it. Break it down into prime pieces. You got a couple examples to do here, C and D, and we'll see you next time. Thanks for watching.